Hello students, in the last class we have started applications of derivatives and we have completed what is a derivative as a rate measure, and we have also discussed monotonicity. In this class we will solve few problems in monotonicity, remaining problems, and then we will go to the next topic, next concept in this chapter. Oops. One moment. Applications of derivatives. We have already completed derivatives as a rate measure, and then we have started monotonicity. What is monotonicity? It is the increasing and decreasing nature of a function, that is single behavior of a function. Okay, now we should solve from this question. Now, for finding the nature of function, increasing and decreasing interval of the function x power x, what is the procedure for finding monotonicity? We should first find f dash of x. And how to find f dash of x? For finding f dash of x, when there is a function in base and there is a function in power, then we need to take log on both sides first. That means we will take y is equal to x power x. We will first consider y is equal to x power x, y is equal to x power x, and then take log y. Log of y will be log of x power x, log of x power x. And what is x power x? Log x power x will be, this power will come to the front, then we will have x into log x. Next, what is the step? Differentiate. Differentiate on both sides with respect to x. Then what we will get? Log y differentiation is 1 by y into dy by dx. 1 by y into dy by dx, that is equal to x log x differentiation is x into log x differentiation is 1 by x plus log x into x differentiation is 1. So what is the final answer? These two will get cancelled. Here we will have 1 plus log x. So what is dy by dx? Which implies dy by dx is equal to y into 1 plus log x, and what is y? X power x. So x power x into 1 plus log x. This is the derivative dy by dx. Next, what we should find for increasing and decreasing nature of the function, this dy by dx should be greater than 0. This is f dash of x. This should be greater than 0 means this function is increasing. This is f dash of x, where y is f of x. This is f of x. Okay. Now what is f dash of x greater than 0 implies x power x into 1 plus log x should be greater than 0. X power x is a positive quantity because a power x term for a function to be defined, this is always a positive quantity. Here if we have negative in base, this will become a relation. This is not a function. So when x power x is a function, always base should be positive. That is the prerequisite definition of x power x, exponential functions. Then that means this is a positive quantity, means 1 plus log x should be greater than 0, which means 1 plus log x should be greater than 0, which implies log x should be greater than minus 1, which implies x should be greater than e power minus 1. And what is e power minus 1? 1 by e. So x is greater than 1 by e, which means x power x, f of x is increasing in interval 1 by e to infinity. Then what is decreasing interval? The other region will be decreasing interval. When f dash of x is negative, then the function will be decreasing. Then what is the answer? Here x will be less than 1 by e. Same procedure. That means between minus infinity to 1 by e, this is a decreasing function. Now we will see the solution for this. Let f of x equal to x power x. First we will take log. That means log of f of x will be, by using the property, if power is there, that power will come to the front. That means x into log x. Then differentiate on both sides. 1 by f of x into f dash of x equal to 1 plus log x. So that means f dash of x equal to x power x into 1 plus log x. Then what we need to do? F of x is increasing in the interval. F dash of x is greater than 0. That means 1 plus log x should be greater than 0, or log x is greater than minus 1. That means x is greater than 1 by e. So this is the increasing interval. What about decreasing interval? Again, when f dash of x is less than 0, f of x is decreasing. We already know what is the condition for increasing and decreasing functions. So that means x is less than 1 by e. That means f of x is decreasing in the other region, that is 0 to 1 by e. And why here we are writing 0? Because base is positive and log x will be defined only when x is greater than 0. Therefore we will take x values that are greater than 0. So here domain is from 0 to infinity. So we will consider only the positive regions. Next question. Find the intervals in which f of x equal to sin x minus cos x, which is defined on, within this interval we have to check whether this function is, what is the interval in which it is strictly increasing and strictly decreasing. So between 0 to 2 pi, what are the intervals in which f of x is, that is sin x minus cos x, is strictly increasing and strictly decreasing. Now again, what is the procedure, students? First we will write f dash of x. What is f dash of x? F dash of x is differentiation of sin x is cos x, and differentiation of cos x is minus sin x. So here minus into minus will become plus. So this will be cos x plus sin x. Okay. Next is, when f dash of x is equal to 0, that means cos x plus sin x will be equal to 0, or cos x is equal to minus sin x, which means tan x will be equal to minus 1. Tan x is equal to minus 1. When tan x is minus 1, what is the value of x? Tan will be negative in second quadrant and fourth quadrant, and when this will be minus 1 at 45 degrees. So 90 plus 45 and 275 plus 45 will be the answer for this, when tan x equal to minus 1. Those are the two values here that is required. So this means x will be equal to 135, 90 plus 45, another value is 275 plus 45, that will be 275, 280, sorry, 270 plus 45, that will be 315 degrees. 270 plus 45 is 315 and 90 plus 45 is 135. These are the two values. That means, that is, what is 135? 3 pi by 4, and 315 will be 7 pi by 4. These are the two values, that is x equal to 3 pi by 4 and 7 pi by 4. Next, what we need to do? Mark these values in the number line. 3 pi by 4, 7 pi by 4, and within what interval we need to find? 0 to 2 pi. Next, we should check at what interval. Take some value of x, for which see if it is positive or negative. This is the plot of f dash of x in number line. So when f dash of x will be positive or negative, we have three intervals here, 1, 2, 3 regions. So in these 3 regions we have to check, substitute some value and check if it is positive or negative. What is f dash of x? Cos x plus sin x. Now between say 0 to 3 pi by 4 we can take 90 degrees. Cos 90 is 0, sin 90 is 1, that means f dash of x is positive here. Between 135 and 300 we have 180 degrees. What is cos pi? Minus 1, sin pi is 0, so it is negative number. Between 7 pi by 4 to 2 pi, again we have sin is negative, cos is positive, it will be positive value. So what is the answer, students? It is increasing, f of x is increasing in the interval 0 to 3 pi by 4 and 7 pi by 4 to 2 pi, and it is decreasing in the interval 3 pi by 4 to 7 pi by 4. This is how we should solve these questions. Now we will see the solution. First we have to find f dash of x, and f dash of x equal to 0 means what is the critical points? Tan x is minus 1, that is x will be 3 pi by 4 and 7 pi by 4. Why we are taking only 2 values? Because these 2 values lie in the interval 0 to 2 pi. So these are the critical points that are needed. So these points divide the number line between 0 to 2 pi into 3 intervals. So we have to see at each interval what is the sign of f dash of x. Again, first is positive, negative and positive region. Positive, negative and positive region. This is a graph of f dash of x. This is f dash of x sine curve. So f of x is strictly increasing between 0 to 3 pi by 4 and 7 pi by 4 to 2 pi, and it is decreasing in the interval between 3 pi by 4 and 7 pi by 4. Clear na? Easy questions. Again, another trigonometric function. F of x equal to sin power 4x plus cos power 4x. Between x is between 0 to pi by 2. Now the first step we should see is, in the previous question it is easy to differentiate, so we are writing directly, and before x power x question again we know how to differentiate by taking log, we can do that. For this question, first we can differentiate directly, we already know the procedure for composite functions, or we can also use another method. First try to simplify this f of x. F of x is equal to sin power 4x plus cos power 4x. Next what we need to do is try to simplify this term. This can be written as sin square x whole square plus cos square x whole square. Now what we need to do, this is of the form a square plus b square. What is the formula, students? A square plus b square will be equal to a plus b whole square minus of 2ab. And what is a plus b? Sin square x plus cos square x, which means from this we get, this is sin square x plus cos square x whole square minus 2 sin square x cos square x, sin square x cos square x. Now what is sin square x plus cos square x? That is 1. So this is 1 minus of 2 sin square x cos square x. That can be written as 1 by 2 of 4 sin square x cos square x. Now this is equal to 1 minus this is equal to 1 minus 1 by 2 of, this value is nothing but 2 sin x cos x whole square, that is nothing but sin 2x square. So this is sin 2x square, that is sin square 2x. So this is the actual simplification of sin power 4x plus cos power 4x. Now what we need to do? Find f dash of x. F dash of x will be equal to, differentiation of 1 is 0 minus half is constant and differentiation of sin square 2x, that is equal to 2 times, this is of the form x power n, so formula is n into x power n minus 1, so 2 into sin 2x power 1 into differentiate sin 2x, that is cos 2x, sin x differentiation is cos 2x into differentiate 2x, that will be 2. Now 1 2 will get cancelled. This is equal to minus of 2 sin 2x cos 2x. Sorry. This is equal to minus of 2 sin 2x cos 2x. And what is minus sin 2x cos 2x? 2 sin 2x cos 2x will be sin 4x. So this is equal to minus of sin 4x. Okay, so differentiation f dash of x is minus sin 4x. Now what we need to see? Between 0 to pi by 2, what is the interval in which it is increasing or decreasing? So x belongs to 0 to pi by 2. 0 to pi by 2, which means 4x will belong to 0. 4x less than or equal to 2 pi. So we need to see the interval between 0 to 2 pi when this will become positive and negative. Correct now? 4x, sin 4x will become 0 means what is the interval? Between 0 to 2 pi. That is how we should solve these questions. Now we will see the solution. I will solve it here. Okay. 0 to 2 pi, between 0 to 2 pi, when f dash of x will become 0. F dash of x equal to 0 means sin 4x should be 0. Sin 4x should be 0, which means 4x will be n pi. Sin 4x equal to sin n pi, which means x is equal to n times pi by 4. Now x is equal to n pi by 4. Now what are the possible values of x? Between 0 to pi by 2, which means we have x is equal to 0, pi by 4, 2 pi by 4 is pi by 2, so we have pi by 4. That is the answer here. So this means we have x is equal to, in the number line, 0, pi by 4 and pi by 2. We have two intervals between pi by 4 to pi by 2. What is the value? If this value is positive or negative, minus of sin 4x. Now what will be, when x is pi by 4, 4x will be pi, 4x is pi. Now between pi to 2 pi, sin value is negative, that means minus sign will be positive. So this region is positive. And what about the before region? Take between 0 to pi by 4, that means 4x will be between 0 to pi, so sign is positive, minus of positive number will be negative. That means f dash of x is positive in pi by 4 to pi by 2 and negative in 0 to pi by 4. So f of x will be increasing in this interval pi by 4 to pi by 2 and decreasing in the interval 0 to pi by 4. That is the answer. Clear now students? Easy questions. First we have to try to simplify this question. So differentiation becomes easier. After that what we did? Find the critical points, that is when f dash of x equal to 0, when f dash of x equal to 0, x is equal to pi by 4. So divide this interval between these two regions 0 to pi by 2 into different intervals. Here we have only one number critical point, that is pi by 4. So we have two intervals, and then try to substitute some value in this interval and see if this f dash of x is positive or negative in the corresponding intervals. So here first region is minus and second region is positive. This is the sine curve of sine of f dash of x. So that means in this first interval 0 to pi by 4 it is decreasing function, and in the other interval it is increasing function. Now we will see the solution. First step is to try to simplify this. So 1 minus half sine square 2x is the actual simplification of this curve. Then what we need to do? Differentiate this. Find f dash of x, that is equal to minus of sine 4x. Now f dash of x greater than 0 means that is increasing region. when this value is greater than 0, minus of sin 4x should be greater than 0. That means sin 4x should be less than 0. So 4x will be between pi to 2 pi. That means x will be between pi by 4 to pi by 2. So in this region it is an increasing function, and in the other region it is decreasing function. Next question. Until now we have seen in what intervals the function f of x is increasing or decreasing. Another type of question can be, show that this function is decreasing in the interval or increasing in the interval. Then what we need to do? Again we have to follow the same procedure. First find f dash of x and see if this critical point and divide into intervals and see if it is decreasing or increasing in that interval. Procedure is same. This is just another variety of question. Now what is f of x? Cos square x. What is f dash of x? F dash of x will be 2 into cos x into differentiation of cos x. 2 into cos x into differentiation of cos x is minus sin x. That is equal to minus 2 cos x sin x. Minus 2 sin x cos x is minus of sin 2x. So f dash of x is minus sin 2x. Then what we need to do? Again f dash of x equal to 0 means f dash of x equal to 0 means okay, f dash of x equal to 0 means sin 2x will be equal to 0, which means 2x is pi, so x will be pi by 2. X will be pi by 2 or 0. We have two values, 0, pi by 2, pi, etc. in intervals of pi by 2. Then what we need to do? F dash of x is less than 0. See, f dash of x is less than 0. That means minus of sin 2x is less than 0. Minus of sin 2x will be less than 0, which means sin 2x is greater than 0. Which means when sin will be positive, between 0 to pi, sin is positive. So between 0 to pi, sin 2x is positive. That means 2x is between 0 to pi. That means x will be between 0 to pi by 2. Which means 0 less than x less than pi by 2. That means f dash of x is less than 0 in the interval 0 to pi by 2. This is the proof. That means f of x is decreasing function in the interval 0 to pi by 2. So first step is to differentiate, find f dash of x, and this is the interval between 0 to pi by 2 we have to find. So 2x is between 0 to pi and sin 2x is positive in the interval. So f dash of x will be minus of sin 2x, that is negative. That means f of x is decreasing function in this interval. Next, another question is, show that f of x equal to x plus 1 by x is increasing in the interval 1 to infinity. Okay. Again procedure will be same. F dash of x will be, what is f dash of x? Differentiation of x is 1 minus differentiation of 1 by x. What is the differentiation of 1 by x? That is minus 1 by x square. 1 minus 1 by x square. And this function need to be increasing. That means f dash of x greater than 0 means 1 minus 1 by x square minus 1 by x square should be greater than 0, which means x square minus 1 by x square should be greater than 0. Again denominator is always a positive quantity. X square will be a positive term. That means x square minus 1 will be greater than 0. And factorize. This is of the form a square minus b square. So we have x plus 1 into x minus 1 greater than 0. Which means try to plot in number line. between minus 1 to 1, in which interval this function f dash of x is positive. This is f dash of x sine of f dash of x. That will be between minus 1 to 1, take 0. 0 minus 1 is negative number, minus 1, 0 plus 1 is positive. So positive into negative is negative. Then take some other number after 1, 2. 2 minus 1 is positive, 2 plus 1 is positive. Positive into positive, positive. Take another number minus 2 in this interval. So again we will have minus 2 minus 1, negative number, minus 2 plus 1, again negative number, negative into negative is positive. So what we need to prove? Show that f of x is increasing in 1 to infinity. Obviously sine of f dash of x is positive between 1 to infinity. That means f of x is increasing in 1 to infinity. That is the proof for this question. Simple questions. So first we will find f dash of x. For f of x to be increasing, f dash of x will be greater than 0. That is the condition. That means x will be between minus infinity to minus 1 and 1 to infinity. So between in the interval 1 to infinity, f of x is increasing. Next question. Show that f of x equal to mod x is strictly decreasing on the interval and increasing on the interval this given. Okay. Now the first step, f of x is mod x. What we need to do first is to try to break the modulus function into different parts. That is the easiest way to solve this question. First thing, always whenever modulus function comes, try to break into functions that is easily differentiable. You know the differentiation of that function. So what is mod x? That is equal to x when x is positive, and this is equal to minus of x when x is negative number. Then what we need to do? By observation, we already know graph of mod x. Mod x is a v-shaped curve and it is continuous function. Whenever it is a continuous function in the open interval, whenever we have a continuous function in the open interval, that means we can differentiate directly. Otherwise, we should not differentiate directly. As we already know, mod x is a continuous function. That means we can write f dash of x directly. F dash of x will be equal to differentiation of x, that is 1, and differentiation of minus x, that is minus 1 in the corresponding intervals, that is x greater than 0 and x is less than 0. And whenever we are differentiating a function, try to write in open interval. Differentiable condition will always be in open interval. Why is that? Because at the end point we are not considering the differentiation, as it is a piecewise function. So always whenever we have a different pieces, different categories or different types of functions in different intervals, then always write this value in open interval, that is x greater than 0 and x less than 0 and corresponding differentiation values. Now by observation, what we need to prove? F dash of x is positive, means it is increasing, negative means it is decreasing. Here f dash of x is positive in the interval when x is greater than 0. That means it is f of x will be increasing when x is greater than 0, and f dash of x is negative number minus 1. That means f of x will be decreasing when x is less than 0. So f of x is decreasing in the interval when x is less than 0. That is the easiest way to prove this question. Now we will see the solution. What is f dash of x? That is equal to mod x by x. And again we can write f dash of x as mod x by x. When mod x is positive, that means we will have x by x, that is 1. When x is negative, then we will have minus x by x, that is minus 1. That is what is written here. Easy, not clear? So from this we can write f dash of x is equal to negative number when x is less than 0 and positive number when x is greater than 0. So f of x is decreasing when x is less than 0 and increasing when x is greater than 0. That is it, easy. Next topic is maxima minima. Okay, next topic is maxima minima. Again, this is a very important topic. there will be many questions based on this. It is useful for both mains and boards, and you can expect questions based on this topic in 2 mark question, 3 mark question, and again objective question, 1 mark questions can also be asked from this. This is a very important topic, maxima or minima, and it is a very simple topic to understand. Until now we have discussed what is a derivative as a rate measure and then monotonicity. By using derivatives we have seen, and now what we need to see is in this topic maxima or minima, which the word itself means maximum and minimum values of a function. That is the simplest understanding of this topic. Maxima or minima implies maximum value and minimum value of a function. At what point the function becomes maximum and at what point the function becomes minimum. That is it. So maximum value of f of x, that is maxima. For example, consider the graph f of x as shown below. Now in this graph, by observation, what will be the maximum point? That will be this point. And we are taking two values. We are taking two values between, take this point as a minus delta or a minus h, and other value is a plus delta, where delta is a small quantity in the neighborhood. That means in the neighborhood of point A, if A is a point of maximum, that means f of A will be greater than f of A minus delta and f of A will be greater than f of A plus delta. That is the easiest understanding of this topic. When this point will be maximum, this will be the maximum point in its neighborhood. A is the maximum point. A is the maximum point in the neighborhood of A. So this is f of A will be get the maximum value in its neighborhood. Then we will call this is a maximum point. A is the maximum point or point of maximum. So maximum value of f of x implies f of A will be greater than f of A minus delta and f of A will be greater than f of A plus delta, where delta is a small region, small increment or decrement based on where we are seeing, and it is a small quantity, small change. So in the neighborhood of f of A, as f of x is a continuous function, for a continuous function in the neighborhood, this will be the maximum value. So that means it is a maximum. Thus for all x in a small neighborhood a minus delta to a plus delta, f of x will be less than or equal to f of a minus delta and greater than f of x will be less than or equal to f of a plus delta. That is the definition. Easiest understanding is this. And what does that mean? At this point of maximum, when this is a continuous function, when we try to take tangent, tangent is nothing but f dash of x. So when we draw a tangent, what will be the slope of tangent? This tangent slope will be acute angle, so it will be positive, and when we draw from the other side, it will be obtuse angle, so tan theta will be negative. So what is the condition? F of A will become maximum for a continuous function and a differentiable function. F of A is the maximum value, or A is the point of maxima when f of x, f dash of x changes its sign from positive to negative. That is the condition. Minimum value is just the opposite, ulta. So again in the neighborhood of f of A, in the neighborhood of A, again we will take a small value delta in the neighborhood of A. This f of A will be the minimum point in this interval. So f of A will be less than or equal to f of A minus delta and f of A will be less than or equal to f of A plus delta. That is the definition of minimum. And again what will be the slope of this? This slope is actually negative and this slope is positive. That means f of x, f dash of x changes its sign from negative to positive. That is the point of minimum, and this definition is applicable for continuous and differentiable functions. So f of A is the minimum. So what is the actual definition of maxima or minima? This f dash of x test, slope of derivative will be applicable only for derivable functions. Here this, for finding maxima or minima, the function need not be differentiable. So what we need to do is take the basic definition. What is the definition of maxima or minima? A function will be maximum when in the neighborhood of that function, that value is the maximum among the all the values in the neighborhood. Similarly, function is said to be minimum of f of a, that will be when f of a is the minimum among the all values in its neighborhood. That is the easiest understanding of maxima or minimum. So in the neighborhood of a, this f of a will be the minimum value in the entire interval. That means f of a is the minimum value or point of minimum. When we talk about point of maximum and point of minimum, generally we will consider the x value, that is a here. Right now, so whenever we want to find the point of extremum means maxima or minimum value. So whenever we want to find the maximum or minimum value, we have to take point of extremum means x value. Next is stationary points. And what is a stationary point? We have already discussed in monotonicity. Stationary points are points in which f dash becomes 0. F dash of x equal to 0. That means when function changes its slope from positive to negative or negative to positive, obviously at one point there will be 0. And those points are called stationary points. So what is the definition of stationary point? F of x, f is said to be stationary at a when f dash of a equal to 0. That is the definition. Further, f of a is the stationary value of f at a. So what is stationary point? Stationary point is when f dash becomes 0, and the point at which f dash becomes 0 is stationary point, and stationary value is the value of f dash of a, f of a. So stationary value means f of a, and stationary point means the value of x corresponding to that. For example, find the stationary points of this function. F of x equal to 2x cube minus 9x square plus 12x minus 3. The first step is to understand f of x is this. First you need to know the domain of this function. Always keep in mind, first step is to understand the domain of functions. So what is the domain? As it is a polynomial function, domain is entire real number. Then what we need to do? Find f dash of x. F dash of x is equal to, differentiate this, what we will get? 2x cube differentiation is 2 into 3 6x square minus 18 into x plus 12. And this is equal to, 6 is common in all the terms. This is equal to x square minus 3x plus 2. That is 6 into x minus 1 into x minus 2. So f dash of x equal to 0 means, f dash of x equal to 0 means, what are the possible values of x? 1 and 2. 1 and 2. So stationary points means, find the stationary points means x equal to 1 and 2. Stationary value will be f of 1 and f of 2. Now we will see the solution. F of x equal to this. First we will differentiate this, that is f dash of x. F dash of x equal to 0 means we will get x square minus 3x plus 2 equal to 0. So x equal to 1 or 2. X equal to 1 or 2. When x is equal to 1, what is f of 1? Here we have to substitute in the function that is given in the question. F of 1 means we have to substitute in the function. Don't substitute in f dash. That is the common mistake everyone, all the students make while solving this question. During exam time, due to pressure, they may see the function differently and just substitute in f dash. Always try to remember stationary value. When you have to find the value, always substitute in the function that is given in the question. That is the understanding basics. You have to remember this, always keep in mind. So f of 1 will be some value, that is the stationary value at 1. Similarly, when x is equal to 2, what is f of 2? Again its value is given. So then the points, stationary points will be at 1, 2. So 1 comma 2 is 1 point, another point is 2 comma 1. So 1 comma 2 and 2 comma 1. This is how we should solve these questions. Next, what is critical point? Again we have seen critical point and stationary point during theory in monotonicity. What is a critical point? Critical point is a point at which f of x does not exist, or f dash of x equal to 0, or f dash of x does not exist. So if f is a function for all values of a, x equal to a is a critical point of the function when f dash of a equal to 0 or it does not exist, and those points are called critical points. Also, when f of x is not defined, those points are also included in critical points, and critical points are always the interior points. This is very, very important. Critical points are always interior points in the function. If it is a boundary value, don't take that value. It should be always within the open interval. For example, find the critical points of this function. F of x equal to x minus 2 power 2 by 3 into 2x plus 1. Okay, f of x equal to this value. What is f dash of x? As it is a product of two functions, first we will take this value 2x plus 1 into differentiate this function u dash v plus v dash u. So u dash will be x minus 2 into 2 by 3, x minus 2 power 2 by 3 minus 1, that is minus 1 by 3, plus keep this value as it is, x minus 2 power 2 by 3 into 2x plus 1 differentiation is 2. So this is the answer. Now what is the f dash of x? Try to simplify this. 2 by 3 of 2x plus 1, x minus 2 power minus 1 by 3 is 1 by x minus 2 power 1 by 3 plus 2 times of x minus 2 power 2 by 3. Now try to simplify this. 2 is common. We can multiply and divide by 3. Then denominator will be common. We can take 3 outside. 2 by 3 into, take LCM. When we take LCM, these two will be cross multiplied. Then we will have 2x plus 1 plus 3 times of 2 by 3 is outside, remaining will be x minus 2 power 2 by 3 plus 1 by 3 will be 3 by 3 divided by x minus 2 power 1 by 3. And what is this value? 2 by 3 into x minus 2 power 1 by 3 of, remaining terms will be 2x plus 3x is 5x plus 1 minus 6, that is minus 5. Now what we need to see, when f dash of x becomes 0, that is a critical point, or when f dash of x is not defined and f of x is not defined. So in this question, f dash of x becomes 0 or not defined when f dash of x equal to 0 or not defined at x is equal to, when x is equal to 1, numerator becomes 0, 5 into x minus 1. So when x is equal to 1, this numerator becomes 0, so f dash of x is 0. Or not defined at, when x is equal to 2, denominator becomes 0, that means f dash of x is undefined. So what are the points? When x is equal to 1 or 2. These are the critical points. Then for finding the critical points, we have to substitute. When x is equal to 1, what is the value of f of 1? Similarly, when x is equal to 2, what is the value of f of 2? We have to substitute in the point and write the value points. So f dash of x is given like this. So f dash of x is not defined at x equal to 2. So this point will be considered for critical point. Also f dash of x equal to 0 means x is equal to 1. These two are critical points. For the same question, if you have to find stationary point, that means f dash of x equal to 0. So we will only have one point, that is 1. Hence f of x equal to 1 and 2 are critical points of f of x. Next topic is global maximum and global minimum. Until now we have seen what is the maximum and minimum of function, and especially we have seen maximum and minimum value in the neighborhood of a point. When we consider only a small region near the point, that means it is a locally bounded region. So what we are actually finding is local maximum and local minimum. In other words, that is called local extremum or extreme values. All terms are same. Here what is global maximum and global minimum? In the entire value of the function, whichever is the maximum value, that is the global maximum, and whichever is minimum value, that is global minimum. So what we need to find is find all the local maximum and minimum values and also the boundary values, and see which is the maximum value among all the values and minimum value among all the values. The maximum value is global maximum and minimum value is global minimum. So greatest and least values. What is the maximum? It is the maximum value among all the values, and minimum value is the minimum among all the values. Minimum or least value or local, global, extreme, global minimum, all are same. Greatest value or maximum value or absolute maximum, absolute minimum for minimum value. So all these terms denote same, global minimum and global maximum. Whenever there is a term global maximum, that is the greatest value in the interval, whatever is given in the question. Similarly, global minimum means which is the absolute minimum value of the function. For example, sin x varies between -1 to 1, we already know. So what is the global maximum of sin x? That will be 1, and global minimum is -1. This is the minimum most value. So maximum and minimum value is defined like this. Out of all the values, which is the maximum and which is the minimum value. Next one, a function defined on a set need not have maximum or minimum values in that set. This is very important to understand. A function need not necessarily have a maximum or minimum value. We will see an example for that. Example, f of x equal to x cube. What is the graph of x cube, students? F of x graph will be, x cube graph will be like this, and in the interval r, in all the real numbers, when we consider what is the minimum most value at -infinity, f of x is minimum, and that is -infinity. And what is -infinity? It is actually undefined value. So as we don't have any finite number that quantifies this, that means we will take the global minimum value does not exist. Similarly, what is the maximum value? Again it will be infinity. So that is not a defined value, defined number. So that means global maximum does not exist. But if we restrict the interval, say between -2 to 2, global minimum will be at -2 and global maximum will be at 2. This is how we should see. Clear now? So when we have all the values, take the entire domain and see whichever is the maximum and whichever is the minimum value, and in some cases global maximum and minimum value may not exist. Similarly, local maximum minimum value may not exist for some functions, and also for some functions maximum value exists but minimum does not exist, or minimum exists, maximum does not exist, or sometimes both may exist. The basic understanding is maximum is the maximum value among the entire values in the interval, and minimum is the minimum value among all the values in the interval. For example, another case, f of x equal to -x square. What is the graph of -x square? This is f of x equal to x cube. F of x equal to -x square graph will be, f of x equal to -x square graph will be just reverse of mirror of x square graph in x axis. That will be like this. Again, does this graph have any minimum value? No, it tends to -infinity, but it has a maximum value, that is 0. Similarly, when we consider f of x equal to x square, its minimum value will be 0 and maximum value is undefined. Sorry. Next is A function need not be differentiable to have a maximum or minimum value. A function need not even be continuous to have a maximum or minimum value. For some functions, we just need to see the basic definition of maxima or minima. What is maximum? It is the maximum most value. Maximum value in the neighborhood of that point. Similarly, minimum is the minimum most value in the neighborhood of that point. So we should always keep in mind the basic definition to find maximum or minimum. A function need not be continuous, it need not be differentiable to have a maximum or minimum. Right now, so in the previous topics, for example, derivative was a rate measure as well as monotonicity. Derivatives are very crucial for finding the function nature. Here for this maximum or minimum topic, a function need not be continuous, it need not be differentiable. We don't need to think about those things as long as there is a function given an interval and in a domain. If it has a minimum value or maximum value in its neighborhood, then we will find a local maximum or minimum value for that function. So for example, consider the graph of mod x. We already know the graph of mod x, that is V shape. Mod x will be V shape function. At x equal to 0, it has a minimum value, and whenever there is a sharp point in the function, it is not differentiable at that function. But mod x is continuous function. And what is the minimum value? At x equal to 0, its value is 0. And in the neighborhood of 0, f of 0 is the minimum most value. That means this is the minimum value. F of x has a local minimum at x equal to 0. What is absolute maximum or minimum or global maximum or minimum? We have already discussed what is absolute maximum and minimum. We will just go through this. Global maxima or minima would always occur at critical points of the function or at the end points. So whenever we have to find the global maximum or minimum, first step is to identify the critical points, and then we have to find the values at the critical points as well as at the end points. That is the constant, same procedure for all the finding the values of global maximum or minimum. Global maximum or minimum, for finding this, first step is to identify the critical points. That is when f dash of x equal to 0 or does not exist. Let these be critical points, C1, C2, C3. Let there be n critical points in the interval a to b. Then f of C1, f of C2, f of Cn will be the critical points values, and these values may or may not be maximum or minimum values. But at these values, the function exhibits maximum or minimum nature. That is for sure. So what we need to find is, find all these values and also find the boundary values. That is f of a and f of b. And find the maximum most and minimum most value. That is global maximum is equal to maximum of boundary values, that is f of a and f of b, and values at critical points. Minimum value, absolute minimum or global minimum will be minimum most value among this, that is f of a, f of b, and critical points values. Global extreme values, that is global maximum or minimum. Again, f of x is a function defined in closed interval a to b. Global maximum and minimum values are called global extreme values. Find the global maximum and minimum value of f of x equal to x square in the interval. Again, easy question. We already know the graph of f of x equal to x square. X square will be always greater than or equal to 0. We already know that. So what is the minimum value of this? 0 is the minimum value. Maximum value will always tend to infinity. So 0 is the global minimum of f of x, and infinity is the, or maximum value is undefined. Easiest way to see global maximum and minimum or local maximum and minimum is to draw the graph and observe. X square graph is like this. Its minimum value will be at 0, maximum value is undefined. Easy questions. Next is, when f of x equal to this value is a local maximum or local minimum, then these values are also called local extremum, or in general just extreme values of function f. Now when a function has a local maximum or minimum value, then at those points its differentiation derivative will always be 0. When a function in its neighborhood of a, f dash of a exists and its value will become 0, then at those points this function will exhibit maximum or minimum value. But whenever this function is defined on a neighborhood and f dash of a equal to 0, those need not necessarily be the maximum or minimum value. Now what is the difference between these two? Function on the neighborhood of a and f dash of a exists, then at the maximum points derivative will be 0, but not at all points where derivative is 0 function exhibits maximum or minimum nature. We will discuss this with an example. Consider a function f of x equal to x square, another function f of x equal to x cube. Now at what values this will be? F of x equal to x, f dash of x will be 2x, and here f dash of x will be 3x square, and f dash of x equal to 0 implies x will be 0. Again here f dash of x equal to 0 implies x will again be 0. That means by the definition, what is the maximum or minimum value for this curve? When we consider a graph by observation, this point 0 is the minimum value. That means f of 0, that is the minimum most value of this function. So 0 is the local minimum. What about the maximum value? It does not exist. So for this function, x is equal to 0 is a critical point, that is when f dash of x equal to 0, and this is the minimum value. What about this case? F dash of x equal to 0 means x equal to 0, and what is the graph of x cube? X cube graph is like this. So what is the minimum and maximum value? This function does not have a minimum or maximum value. Why is that? By looking at the basic definition of f of x, that is minimum or maximum values for f of x, what is the definition? Here f of 0 is the minimum in its neighborhood. What about this case? F of 0 plus, that will be greater than f of 0, that is 0. F of 0 minus, that will be less than f of 0. What is the definition? This 0 should be the minimum most value in the neighborhood. That condition is not satisfied. F of 0 is less than f of 0 plus. F of 0 plus means limit f of x. Similarly, f of 0 is greater than f of 0 minus. This should not exist. Both should be less than. That means f of 0 is the minimum value. Here both should be greater than means it is the greater or maximum value. That condition is not satisfied in this case. So this, for this function x cube, even though f dash of x equal to 0 means x is a critical point, x equal to 0 is a critical point, but this does not have a maximum or minimum value. Next is extreme values. F is a function defined on the closed interval a to b. Relative maximum or minimum value of x is called extreme values. This is the condition. What is it? For at the local maximum or minimum values, its derivative will be 0. But whenever derivative is 0, it does not mean that function has a maximum or minimum value. For example, just now we have discussed this example. Again same example, f of x equal to x cube means x is equal to 0, but f of x is greater than f of 0 and when x is greater than 0, and f of x is less than 0 when x is less than 0. That should not be the case because it violates the basic definition of maximum and minimum for function. That means x equal to 0 is neither maximum nor minimum for this function. Next is finding methods of extreme or extrema for a continuous function. Finding methods of extrema for a continuous function. We will discuss this topic from the next class. We will continue from the next class. And always remember students, keep learning and keep growing with Tapasya. Success is yours line by line. Endigu endendigu namma Tapasya.